IPSec is having few outlines. So we are going to discuss all about the introduction part, like features, elements, and what is the scenario where we can see IPSec as a priority. Next, we are going to say its architecture and then the benefits and the applications. So coming to the IP security, this is a standard which is provided by IETF as a IP, I mean Internet Protocol Security purpose. So this is done at the IP networks. So IP security will be provided at the IP networks, which are moving from one router to another router, or else from LAN to WAN or WAN to MAN. So this is variating the access points, right? So when we are moving from one access point to the other access point, how can we provide security? So once we security, what are the terms we should be providing and what are services we have to provide are authentication, integrity, and the confidentiality, right? So for this, how IP security is playing an important role is about the IPsec. Now, this is providing data security at the IP packet level. See, data security is nothing but the confidentiality. We can provide data to be encrypted whenever we need, right? So this is what about IP security introduction, why and how, right? So this can be included with a proper header and the payload. Every time the payloads, whatever we are discussing, are called as packets in the IP security. So these packets to be maintained properly without getting eavesdropped by some other intruders in the network. So that is our main intention to follow up with the IP security. Now, what are the features it can provide to us? We can provide authentication to us, integrity, and the confidentiality. So all the secure methods, whatever we need in the network sites, we will get that. So coming to the authentication, it will verify each and every packet received. Okay, so that is the first thing for the authentication. So who is sending the data, who is sending that packet? Every time we will be noting that. Next, integrity. So integrity is nothing but we are going to ensure that the data has been not changed. The packet has been not changed in between. So the packet has been not changed in between. Confidentiality means we are going to encrypt the packet message content through encryptions. So we are going to conceal the message. So these are the three features an IPsec can provide. So now coming to the elements. So what are the major elements we are going to include in the architecture also are ESP, AH, and IKE. So encapsulating security payload will be responsible for encrypting your payloads, okay, along with the authentication and integrity procedures. AH is separately responsible for authenticated user and the message. Okay, authenticate the user and the message. AH is responsible for that. And IKE is responsible for transmission of your keys between a number of access points. So along with the key management, we have a separate concept, that is security association in IPsec. So this security association is very, very important because at the network levels, we call access points. So these access points, I mean the routers, whatever we have to have a separate policy for that to maintain in a proper way. So for that, we are going to maintain a security association over there. So security association management will be done by IPsec. So these are the elements which are included in the IPsec. Now, coming to the scenario where IPsec is more prior. See, when a user, these are 2-3 users we have. So fourth one. So one user is connected to the Ethernet. The other user is connected directly to the public network. Other two users are connected to the Ethernet in their organization. So this is one organization, this is one other organization. Let us think. Now there is one networking device. So that may be any device which is connecting to the other devices, right? So this is another device which is connecting to the other device. Now users are connecting to their network device users are connecting to their network device, and network devices are connecting to the public internet. So here, once we are saying this communication is possible like this, our payload is moving from one network to the other network. So when this is happening, our data may be changed anytime. The packet may be eavesdropped by an attacker. The packet may be replaced with some other content. That packet may be removed with the sender's details and attach your details over there. So all these may happen. So for this kind of scenario, we need IP security at every access point which is moving from our network to other network to some public network. So this is a area where we have to include IP security as a important version. Now, IP security architecture we have drawn in two ways. So this is the one way and the above one is the other way. So this way is with respect to the IKE. So how we are exchanging the key. So this is with respect to the key exchange. Got this? So IKE is nothing but internet key exchange. So where two parties are exchanging their symmetric key or else asymmetric public and private key combinations are happening. So when we say key exchange, that may be public type or asymmetric type or asymmetric type, right? So this is done with respect to SA. So SA is nothing but security association. So when we are discussing about access point security with respect to IPSec, we need security associations. So security association will be having security policy. So that is SP, security policy. Now security association database will be giving all the keys of the users, whenever user is requesting for a particular key, then immediately it will go through the security policy. If the policy accepts, then you will be getting the key. So this is nothing but a proper procedure with security association. So security association is very, very important in key exchange policy, right? So here we have our SCAD, Security Association Database, will be protected by ESP. See, ESP can provide protect our data. Now coming to the architecture in a next version. See, this is a main architecture we call with all the protocols and all. So now what happens in this is we use ESP protocol for encrypting all the data, for providing integrity, for providing authentications. Now, authentication protocol is responsible for your user authentication and the message authentication. Now, ESP utilizes encryption algorithms. ESP also utilizes authentication algorithm too, because it is also providing authentication and message integrity also. AH provides authentication only, thus it is utilizing only authentication algorithm. And domain of interpretation is nothing but at every step, at every level of your message, we are going to interpret your data one by one. Means every packet will be checked every time, right? So for that we need DOI. At last, we are, after the data is properly done, we are going to see key management. So key management includes secure association over there. So as we just seen in the architecture diagram, right? So the main components which we have seen in the architecture are going to discuss here. So the architecture includes ESP. So ESP is responsible for encrypting your data. I mean, also encapsulating in the header format over there. So you will be attached with the header format of ESP along with the payload encrypted data. So the whole thing we will be providing as a security in IPv4 or IPv6. See, IPv4 and IPv6 are the two protocols at a network layer. So those two protocols itself will be included with IP security as one of the part, right? So then only we can provide security to the IP and many number of access points moving in the network level, right? Next, authentication header is responsible for the authentication of the message and the user. So here the current specifications for authentications are 4302. Next, encryption algorithms we are going to include in ESP. See, include in ESP are used to encrypt our data. So that encryption algorithms may be dependent on the symmetric or asymmetric. If you are utilizing symmetric, we may go for AES or triple DES. If you are going for asymmetric type for the key generations and all, we go for RSA. If you are going for key exchange algorithms, we go for Diffie-Hellman algorithm. So that depends on the algorithms which we are utilizing. Next, authentications. These are used in both the modules of AH and ESP. Right, because ESP is also providing authentication, right? So now the algorithms discussed for authentication algorithms are we have authentications are Kerberos we have, where we are going to discuss about authentication of a particular user. So for there we are also going for integrity. So when we are discussing about integrity, we are going to check about CRCs, I mean checksums also we are going to check at the internet level. So then only we can understand the packet has been not changed in between. Next, domain of interpretation. See, this domain of interpretation is data which is having every line by line updation will be updated in one document. So that document is maintained by DOI. Okay. So line by line procedure, what is happening in the network at that IPv6 or IPv4 will be documented in a proper way, so that every access point will be having that knowledge what is happening. So specifications wise updates will be done. Next is the key management. So key management, how a sender and receiver will be exchanged key between them. We know a number of procedures for that in the public key distribution and symmetric key distribution. Just go through that, right? Next, the benefits. So benefits are nothing but what are the advantages, right? So advantages are like we can include IPsec wherever we want in the LANs everywhere. So without disturbing our exact frame structure, we can include IPsec, which provides a strong security in the LANs, across the LANs and in the Ethernets also. So firewall uses IPsec with checking with all the incoming packets. Okay, if a packet is not authorized one, we are not going to add those packets to enter into our organization. So this is a second advantage. Third advantage is it is transparent to all the applications. So what is happening in the network layer will be having a DOI maintain, and all the procedures which are taking place are transparent to all the applications, right? And when we are including IPsec to be included in any router or firewall, there is no particular software to be installed and all. Directly we can implement on the firewall or router. Okay, so there is no need to change any softwares or any kind of systems to update with IPsec. IPsec can be implemented directly on firewall or router, right? IPsec also can be implemented in individual systems or else any software, say if we want the application layers. So all this is possible without affecting our system. So as we discussed, it is transparent to all the users and it can provide security to an individual system also, right? And the major applications where we are utilizing this are, we will utilize in the LANs and we will utilize in the secure branch connectivities, and we use in the remote access points. So to say extranet, internet connectivities, everywhere we will utilize this for ensuring authentications and confidentiality with the proper key exchange mechanisms. And nowadays we have e-commerce a lot utilized by a number of users. So there we need a secure, strong security protocol to update with this e-commerce applications. So all the e-commerce applications nowadays happening throughout the net are utilizing IPsec for that. Okay. So these are the applications. Now, if you have any doubts in this, please be free to contact in the college or through comments. Thank you.